In the next 10 seconds, 4.7 million Google searches will be made, 69 million WhatsApp messages will be sent, and 1.3 YouTube videos will be watched. And all of this will happen in buildings that most people will never see. So right now, as you watch this video, your data is traveling across the globe to buildings that cost more than GDPs of some small countries and are guarded heavily than most banks. Yet 99% people don't even know these buildings exist, and they are called data centers. But I'm not here just to tell you the basics. That's something you must have already known about the data centers. What I am going to tell you is why these tech giants are spending hundreds of billions of dollars on these facilities, why data centers are the next big things, and why these companies are secretly building AI data centers. When you post a picture to social media, stream a movie, shop online, or even check the weather, your data is stored and processed in one of all these centers. Today, half of the world's data lives in the cloud, which means it is kept on servers in data centers. To give a sense of scale, experts estimate that we will create around 200 zettabytes of digital data by 2025. That's 200 trillion gigabytes. Data centers everywhere will have to store and sort that information, from cute little cat videos to critical business records. A few big companies dominate this cloud world. Amazon Web Services is the largest, holding roughly 32% of global cloud market share. Microsoft's Azure and Google Cloud are next, with about 20% and 11% each. These companies keep adding servers to meet growing demand. Many everyday services rely on these infrastructure. Online shops keep inventory and customer data on servers in data centers. Banks process transactions through these networks. Even our medical records are often stored in them. For businesses, cloud data centers allow small companies to access powerful computing without owning hardware. A local startup can tap into AWS or Azure servers to build an app instead of buying expensive machines themselves. This flexibility is a big reason data centers keep growing. More companies are moving their work to the cloud every year. The next wave of technology, things like 5G wireless, self-driving cars, and smart factories also run on data centers. 5G networks promise super-fast connection with very low delay. To achieve this, mobile operators are building small data centers close to users, often called edge data centers. This way, when your smartphone talks to the network, it reaches a server just a miles away instead of halfway around the world. This makes applications like virtual reality games or real-time language translations work smoothly. Statistics show how huge this trend is becoming. Spending on edge computing is forecast to reach about $260 billion by 2025. Now imagine a self-driving car at night on a rainy highway. It might use radar or camera to navigate, but it also sends large amount of sensor data to the nearby data centers, where powerful computers analyze traffic conditions and update maps in real time. And requirements like these create more importance of edge data centers. Beyond commercial and consumer uses, data centers are critical in advancing science and healthcare, areas most people might not immediately think about. Researchers studying everything from the human genome to climate change rely on data centers to store and analyze massive datasets. For example, one of the fastest supercomputers, the Nostrum system, is housed in the converted CERN in Barcelona. There, it runs simulations on weather patterns, models cancer treatments, and even explores new materials, tasks that would have been impossible on an ordinary computer. In medicine, hospitals and clinics have huge amounts of patients' data, high-resolution MRI scans, genomic sequences, and thousands of lab results. Storing and retrieving this data relies on secure servers in data centers. When a doctor teleconferences with a patient, video feeds travel through the data centers. Even research into new drugs often involves AI models that run on data center clusters, sifting through protein structures to find promising compounds. Environmental science too leans on data centers. To predict hurricanes or track climate trends, scientists process satellite images and census data that quickly becomes terabyte large. Data centers handle this load. Even our leisure and entertainment increasingly depend on data centers. Think about your favorite movies, music, or games. Most of them are delivered over the internet, not from your devices, but from the servers somewhere far away. Streaming video services like Netflix or YouTube use global networks of data centers to quickly deliver high-definition content. And here is the live example. When you started this video on YouTube, data centers pulled the file from the storage, and this is how you are streaming this video right now. Let's talk about online gaming, which has another big user base. Multiplayer games have to constantly synchronize millions of players that is run on gaming servers in data centers. The next generation of gaming is heading to the clouds too. Services let you play console quality games on any screen without owning expensive hardware, because the game runs on the data center and only the video is sent to your screens. And if we talk about numbers, in fact by 2025, cloud gaming is expected to be an $8.17 billion industry with about 293 million users. Augmented reality and virtual reality, like what you see in the futuristic headsets, also need nearby data centers. Rendering 3D worlds in the real time for many users is extremely demanding. As these technologies grow, you can imagine virtual or remote concerts you will be attending through VR headsets. Data centers will play host to entire virtual worlds. Data centers might seem hidden, but they are everywhere once you look. Some are built in ordinary warehouses, others in converted barns and decommissioned mines. One data center is even cooled by glacier water in Norway. These out-of-the-way locations help operators keep cost and temperature down. But now let's come to the main question of this video. What happens next? All evidence points to data centers growing bigger and more numerous. For one, the amount of data we generate keep accelerating. We are already at the zettabyte level, and the emerging trends like AI models, smart devices, 8K videos, and virtual realities will create even more. Studies show that the global demand for data center capacity could grow by about 19 to 22% per year through 2030. And following all this data, let me tell you about this massive joint venture called Stargate Project. In January 2025, OpenAI, SoftBank, Oracle, and Abu Dhabi's MGX announced this collaboration with intent to invest up to $500 billion over 4 years in AI infrastructure. This project is a landmark public-private initiative to build massive new AI data centers across the United States. The project was unveiled with US President Donald Trump and senior officials present as the part of broader AI strategy. Stargate project aims to close the gap between skyrocketing AI compute demand and current supply by building the largest AI infrastructure build-out in the world history. Stargate data centers will be the hyperscale AI factories. Each site will require on the order of gigawatts of power, comparable to small power plants. Compute-wise, these data centers will pack the hundreds of thousands of millions of GPUs. Oracle has begun installing NVIDIA GB200 GPU racks on its Oracle Cloud infrastructure. Future phases will include NVIDIA's next-gen Vera Rubin chips as soon as 2026. The data centers will feature high-speed, low-latency networks and advanced cooling, potentially liquid cooling for racks, though the industry standards are still evolving. The overall design philosophy is scale and specialization. Instead of relying solely on public cloud, OpenAI and partners are co-designing infrastructure capable of hosting future artificial general intelligence. SoftBank's data centers design emphasize scalability and energy management, and Oracle brings enterprise-grade virtualization and cloud-native tooling. The result is a mega factory model, more akin to a chip fab or power plant than a conventional server farm. Energy is a growing concern, but also a reason data centers get built. Many are powered by the renewable sources or located near cold climates to save on cooling. This focus on green data centers not only cuts costs, but also meets global sustainability goals. In fact, as data centers become as critical as electric grids, they are also starting to get stricter regulations on efficiency and emissions. Ultimately, data centers will keep spreading because our world depends on them more every year. In the coming years, expect to hear more about data centers, not just as dry technical subjects, but as the mysterious powerhouses reshaping our economy and daily lives. By then, it will be clear why data centers truly are the next big things.